Power. By the end of this unit, you'll be able to describe the transfer of energy into, out of, or within a system in terms of power. The rate at which energy changes with respect to time, either by transfer into or out of a system, or by conversion from one type to another type of energy within a system, is what we call power. The symbol we use is capital P. The unit is the watt, which we use a capital W. Be careful with that capital W. Or this is a joule per second. Simply put, the average power is the amount of energy being transferred or converted divided by the time it took for that transfer or conversion to occur. In mathematical terms, our average power is our rate that energy is transformed from one type of energy to another, or into the system, or out of the system. Here's a fun derivation we can do with power, considering our average power equals our work over time. Work and change in energy are the same thing. So we can expand it and say work equals force times displacement. We can assume the force and displacement are moving in the same direction. The angle between them is 0, so cosine of 0 is 1. Divided by time. Remember that distance over time gives us velocity. So power also equals force times velocity. Instantaneous power is delivered to an object by the component of a constant force that's parallel to the object's velocity. And you can use this derived equation, FV times cosine of that angle. We can also use calculus here if we are dealing with AP Physics C. The derivative of work with respect to time would give us power. On graphs, you may see a force versus velocity graph. So what's the slope of that graph? What's the area of the area under the graph? Force times velocity would give us power, so that means the area under the left graph would give us power. Remember that force and acceleration are directly proportional to each other, so we could also do the same thing for acceleration times velocity. Just multiply your mass and you would have your net force. So don't forget about all of those relationships we've been building on throughout the year. Now let's look at an example. Student pushes a box across a horizontal surface with a constant velocity. The box has a mass of 15 kilograms and the coefficient of kinetic friction between the box and the surface is 0.2. If the box is pushed for a distance of 10 meters and it takes 5 seconds to travel this distance, calculate the power exerted by the student while pushing the box. For here, you may want to use some of problem-solving strategy. Maybe you've been sticking with the guess method that we learned earlier in the year. That's fine. Stick with it. Something that I always encourage is underline important pieces of information in a problem, especially as you go through and read it. That's going to help save you some steps and save you some seconds and not have to reread an entire problem. For this problem, because we're trying to calculate the power exerted by the student, we can consider the forces acting on the box. This is a horizontal surface, so we know the weight force equals the normal force. And we have this push force by the student with a frictional force in the opposite direction. We know those two are equal because there's a constant velocity. So we can say the stuff that makes it go minus the stuff holding it back will equal 0. Or our frictional force equals our push force. So that means our push force equals mu times our normal force, which is m times g. We know mu equals 0.2. We know our mass is 15 kilograms. And we know g is about 10. And we'll stick with that for this problem. When we calculate that force, so we find out that our push force equals 30 newtons. And we know the work done is going to be distance of 10, 30 times 10 in the same direction, which gives me 300 joules. to find the power, which is the rate that work was done. 300 joules, and it took us 5 seconds. So we have 300 divided by 5, which gives me 60 watts. So that's it. Next, complete practice, the main step. For more practice, there's your AI prompt. Ask each other, ask me, keep asking until you get it.